All right. Everyone here? Cool. Let's get started. I'm Kunal, because as Senior Developer Advocate at Cast AI. Thanks for coming. Day before Easter, so that's impressive. So I'm going to talk about optimizing Kubernetes and something that we do at Cast AI called container live migration. So who agrees with this statement? No? Good. And yes and no, I would say, because Kubernetes does the orchestration bit very well. Everyone knows what this is? Yeah. CNCF landscape. And that's what it was built for, to do orchestration. But as the ecosystem keeps growing, the real challenge is not just running containers anymore. It's also figuring out how to handle the surrounding complexity that comes with it. This is too yellow, by the way. I think it's my filter. The eye filter. There you go. Yeah. So how do you handle this complexity today? CLI ninja skills. So you can either rely on that, or you can embrace automation. That makes your life a lot more easier. But even in today's 2026, Q1 just got over. This is weird. I've been measuring my life in Q1. So I was meeting some friends, and they were like, how's life? And I'm like, yeah, just Q1 just ended. They're like, what? You're using business terms in the world? It's crazy. That I had a moment of realization that, okay. Anyway, so you can either do a lot of manual stuff, a lot of scripting, or you can use automation. But even in 2026, I travel a lot to conferences. People still think that automation is going to take their jobs. Who thinks like that? One person. Okay. So, yeah. And I was talking to...
Guys got a secret, get them please.
I mean, there are people, there are hardcore devs. They're like, I'm not going to touch any proprietary software. I'll do everything my own. And I'm going to do everything manually, and the reason is that I don't have time to automate it, which is a bit ironic. But here's the thing: if you want to succeed in environments like Kubernetes, and it's not just Kubernetes, it's all the virtual layers that are built to simplify the complexity, you need automation. It's not optional. This is how you scale yourself. This is how you get time back and not babysit your clusters. So automation is the key ingredient. You want to have that, and Kubernetes actually gives you a lot of built-in features to do things the right way. Automatically. Think about infrastructure autoscaling, both horizontal and vertical. There are many other capabilities that can handle the optimization and scaling without you doing manual efforts. So it's all designed to help you focus on really what matters and not worry about repetitive tasks. I'm going to talk a little bit about what Kubernetes does. And is it efficient by default? Yes, no? Maybe, someone said maybe. Not really. Out of the box, no. It's not efficient by default. It does give you the flexibility, but it doesn't give you optimization. So it's how you implement Kubernetes is what matters. So you have to configure it, you have to tune it properly, you have to make it truly efficient. It's not just if you start using Kubernetes and you feel like you're going to be optimized. You can have an optimized infrastructure, that's not going to work. We did a report last year. We often see clusters that are heavily underutilized. You'll find this on the Cast AI website pretty easily. We published this annual report, and the data shows that around only 10% of the CPU's resources are actually being used, which means you are paying for remaining 90% that you're not even using. It's just sitting idle. So you are going to pay for it. It doesn't matter if you're using it or not. If you are having that provision, you're going to make Bezos richer, and you're going to pay a lot more money. So let's talk about infrastructure. Let's see what Kubernetes actually gives us to optimize. Let's talk about the infrastructure layer first. What is actually generating cost here? Like I said, it doesn't matter how much you are requesting or how much you're using. If the infrastructure is provisioned, you will pay for it. You will get a cloud bill. It's as simple as that. And Kubernetes doesn't do efficient bin packing. Everyone knows what bin packing is? Bin packing? Yeah, it's just moving your workloads across nodes. So let's say you have 3 nodes and you have one node is empty, one node is full. So essentially, think of like a water and putting water in the jug. So it's like so the jugs are filled like equally, like more efficiently. It's not like you're just running one container in one whole pod and the whole other space of that pod is wasted. So to do that efficiently, Kubernetes doesn't do that out of the box. It's not going to do that. So which means that you're going to end up with underutilized nodes that are sitting idle and you're paying for that. So fix that. Kubernetes offers autoscaling tools. There's the cluster autoscaler. There's an open source tool called Carpenter. Anyone uses Carpenter here? Some people nodding? Okay. There are proprietary solutions like CastAI. So all these solutions are out there to automatically right size and optimize your clusters close to that to cover that efficiency gap. So, but you know you need an intelligent solution that bin packs these workloads. So basically it's constantly checking which of the pods can be moved to a better fit node. If a node is already like full, if a node is empty, let's say there's one node that has some capacity left and there's another node that only has like 1% of pods running, you should just move it to the node that has capacity left and remove that node because it's going to save the money. But do remember that when we talk about moving a pod in Kubernetes, it really means that you're terminating that pod in one node and then you're starting that pod in another node. So if you're moving the pod from node A to node B, Kubernetes is going to kill the pod on node A. It's going to start it on node B, and that's how it's basically moved. And that's why you need multiple replicas, because you want to build an application that can tolerate this restart. So it's not like it's magically moving the pod, it's just killing that pod and then it's starting it again with the same data. That's it. So if you don't design for that, you will get downtime. Obviously, if you only have one replica and the pod is going down, you're done. The application won't work till it restarts on the second node. And you will get state loss as well, because if there is caching involved and the pod goes down, that cache is gone. It's done. When it starts again, it starts with 0. There's no cache in it. If you had a long running job, for example, let's say AI ML job that was running for a while, there was like 8 gigs of cache in it, pod dies, that's gone. You just start it again. Right? So we're trying to avoid that. And if we do this right, this is what the before and after looks like. So the autoscalers I spoke about, like cluster autoscaler, Carpenter, they're very good at scaling out very quickly, but it's very not so good when we talk about scaling in. The apps shrink, the cluster doesn't shrink. So what I mean by that is you get this blue line, which is there are a lot of provisioned resources, but no workload is using them, but you are still paying for it. Doesn't matter if you're using it, if it's provisioned, you will pay for it. You will pay for that infrastructure. We want that. We want a strong bin packing and smart instance selection. So your workload should know which instance I should run it at. I don't want to pay for stuff that I don't need. So the gap is the wasted money. You can see more money wasted here. If you tighten it with the bin packing, smarter nodes, very aggressive downscaling, it's going to reduce that gap and you're going to have a lot more optimization. So essentially you're just going to pay for what you're using. Another problem, instance sprawl. In AWS Frankfurt region, for example, there are hundreds of instance types. You can't keep a real-time view of all the prices of these instances, also the specs, what the availability is like, and people just use the safe ones that they feel like are, that they are familiar with, and they miss some instance types that might be a better fit. So you would need to have an intelligent system that can basically continuously compare, okay, AWS is giving me 100 types of instances, I am running this workload, then what kind of instance type works well for this workload based on the price, the specs, and if it's actually available in the market. It matches the CPU, the RAM, the GPU requirements, everything to the right need. It also considers spot versus on-demand instances. Everyone knows what spot instances are? Everyone who doesn't know, I can explain. So a spot instance is basically, let's say you are renting a machine from AWS, they give it to you at 90% discount. Why would they do that? There's a catch. They can take it away anytime. So that's spot instances. You get heavy discount, it's not reliable, they will take it away anytime. I think AWS gives like a 2-minute warning. Let's say you're running something on that instance, your Kubernetes cluster, you will get a discount on 90%, but AWS will take it away in 2 minutes. I don't know, I think it's 30 seconds on GCP, I'm not sure, but it's like they will just take it away anytime. And yeah, I mean, that's another issue. On the other side, like which type of instance to use, there's on-demand, there's reserved instances, there's spot instances I just told you about. People usually have a mix of these depending on the organization. Reserved instances can be a little bit risky if your workloads are changing very frequently, because with reserved instances with the cloud provider, you are making a long-term commitment. You're ending up, if your workload requirements change, that you're going to end up paying for something that you have not, you don't have the capacity for. On-demand instances, quite popular. These are flexible. So on demand, I need it, I don't need it, but you pay a high price for this. This is like the most expensive ones. And spot instances I already told you about. These are ideal when your workloads can tolerate interruptions. So 90% discount or 80% discount, but the cloud provider can take it back anytime. So you have to figure out, like, the key is to balance all these three instance types intelligently, commit only when it makes sense, and take advantage of spot instances when possible. But there's a key, like even if you put only 10% of your whole fleet on spot, the challenge here is reliability. As I mentioned, it's cheap, but you are not guaranteed to keep the instance. And yeah, AWS gives you 2-minute notice, Azure gives you just 30 seconds. So when that interruption happens, AWS or Azure are like, I'm taking away your instance. You need to drain that node and you need to start it again, and that takes a while. So you can't be running applications that need reliability on spot instances, right? So you need to have multiple replicas, so same versions of many applications running, so that one application is taken away by the cloud provider of that instance, the others are still running. You need stateless services on spot. You need to keep the critical stateful workloads on the on-demand and reserved instances, because they are stateful, so you can't lose them, you know. So yeah, that's the bottom line. It's going to save you a lot of money, but only if your platform and apps can handle that sort of like tolerance. There is something negative with spot as well, not many people know, because when you buy a spot instance at a certain price, let's say X amount of dollars, that price itself can increase over time. So very worst case scenario, which is quite unrealistic, but you know, never say never. If you run a spot instance for, let's say, 5 months, and the price is now 10 times higher, let's say what it might end up being 10 times higher than what you initially, you know, paid for. So this is why at a high level, you want intelligent automation solutions, which basically the systems that use autoscaling, not manual node management. So which spot instance to use, when to use it, how much to use it, when to drain down the spot instances. The system should know that the instance is about to be taken away, so what do I do with it? All these nitty-gritty things should be handled automatically, because there's no way you can do it without losing your mind manually. And also sizing the cluster based on your real-time usage, which is what I showed you in the graph earlier. That's the goal, smarter autoscaling. So, but that was about infrastructure. What about the workloads themselves? So the workloads running, you know, on top of the infrastructure, you need to take care of both of these layers. I spoke about the infrastructure, but make sure that the applications that are running are also aligned. Very popular, you know, there's a horizontal pod autoscaler, HPA and VPA. Everyone knows about this, pretty standard Kubernetes offering. So horizontal pod autoscaler, as the name suggests, it scales horizontally. It will check your workload, what the load is on that, and if it's increasing, so if the load is increasing, HPA is going to add even more replicas, and the application needs to, you know, tolerate this and handle it properly, so you can like scale out. But with a vertical pod autoscaler, on the other hand, you can see that it basically adjusts the pod requests. So basically, it helps us optimize the requested resources based on real usage. So how people usually do it, let's say for example, is maybe my pod needs 1 CPU, for example, right? Looks fine, I will never touch it again. But you know, this happens all the time. The pod might only need 0.1 of that CPU. So you're burning money and you're wasting resources. So vertical pod autoscaler basically helps bring that up or down. You can combine both of these solutions. The Kubernetes documentation, if you take a look at it, warns you to be careful, because you have to make sure the configurations don't conflict, because your VPA will reduce the requests, and if your HPA goes crazy and starts 500 replicas, then it's not going to be nice. Sort of like counterintuitive. So you have to balance these two out. So if you combine all of these solutions, you end up with a setup that has strong bin packing in place. You set the right instances. Let's say you know all the 100 instance types and you are now selecting those automatically, and you can scale pods vertically and horizontally both. And if we have the option to run a very small cluster, let's say with good utilization, we save a lot of money and we don't need to babysit it. And I don't want to babysit my cluster, I don't want to babysit my workloads, I don't want to babysit my applications. So this is what we do. So you can see nice bin packing, all the pods were moved here. That node is now, I don't need that, so I'm saving money. And HPA, VPA, pod resizing has been done, bin packing has been done, everything's done, life is good. Okay, thanks for coming to my talk. No, I'm not done. It's not always the same, because Kubernetes is a very solid platform, but we still face problems we have in the classic world. I was quite young then. I was born 1999, so I'm talking about VMware before, around that time. So we have made stuff more complex, but that is not a bad thing. Let's talk about what CastAI does with container live migration. What does it actually mean? It basically lets you move pods between nodes in the same cluster with no downtime. So it's not for moving workloads from, if you want to move from cluster A to cluster B or from on-prem to cloud. No, it's not for that. It's strictly, I'm talking about one cluster inside one cluster. So the goal is simple: get a pod of one node onto the another node without restarting it. How does it work? We have two nodes. Let's say, for example, I have a pod named foo123. I'll show you a demo as well. And it has currently an IP address ending in 0.15. I want to move this pod, and I can either trigger it manually or I can let the CastAI platform do it for me. Let's take an example. AWS decided now they want the Spot instance back. So what happens is that it will kill my pod, but I want to drain it safely, and I want to move this pod. And then the event comes in where this pod will be moved from one node to another node. So the technology that CastAI uses called CRIU. Anyone knows what that is? Checkpoint restore in user space. So you can think of it like if you play video games, save game button for your application, like you save game when you're playing video games. It's sort of like that. CRIU, if you want to learn more about it. And what CastAI, what container live migration is doing, it's going to start a migration by creating a shadow pod on the new node. You're going to see the name change slightly, but it handles the identity so the Kubernetes API doesn't get confused. So if it's like a deployment for a stateful set, for example, it's going to keep the same name. The IP address remains the same, so your TCP connection doesn't break. There's just like maybe like a 20 to 50 second no, not second, obviously, 20 to 50 millisecond of lag, which is still better than draining that node and starting it in a new cluster, because that's going to take what, 10 seconds? So it's still much faster than that. So in the background, if I divide it in 3 steps, step 1, while your application is still running and users are chatting with your application, doing whatever, the system is going to start copying its memory into the new node in the background. That's step 1. Then the freeze comes when the copy is almost done. The app is paused for a very tiny window, milliseconds, and this is to sync the very last changes to the memory. We use a forked version of the AWS CNI, so the IP address remains the same. So to the Kubernetes API, it doesn't look like it doesn't look like a new pod has started, right? And then the app wakes up on the new node in the exact same instruction where it was stopped. It still handles all the memory. It can do all the stuff that it was doing before, and we mirror the memory. So once it's fully synchronized, the new pod can just take over seamlessly, and the application continues to run while how you left it on the previous node A, but now it's on node B. So this gives us the stability to run smaller, more efficient clusters, bin packs a lot of workloads very tightly, and you can even run stuff on Spot instances without worrying about downtime. So one of our customers actually quoted that CastAI brings reliability to Spot instances, so that is true. and this is without interruption, no downtime, no restarts. But do you actually need it in Kubernetes? Kubernetes doesn't have this feature built in. Obviously, it treats this as high availability concern that should be handled at the application level, not at the infrastructure level. So the infrastructure layer doesn't care, okay? And Kubernetes itself doesn't manage it. It just assumes that your app will handle it. So Kubernetes by itself is not that efficient. You have to use stuff on top of it. But in the real world use cases, when you talk about customers, a lot of use cases, some of them are quite problematic, especially in enterprise environments. Let's say Kubernetes, I mean, it was in 2014, but it's still new to a lot of organizations. There's a lot of lift and shift that is happening. Teams are moving from on-prem to cloud, from VMs to Kubernetes. But instead of modernizing, they are, they're like, I'm going to move from VM to Kubernetes, but they're not modernizing it. They're just running one huge pod inside a virtual machine. This is happening. And it can't scale horizontally. It takes 10 minutes to start, and you never end up getting the real benefits of Kubernetes. There are companies that run like 95% workloads on it, which is, I'm asking why are you even doing Kubernetes? You're not getting any advantages. You're just having an abstraction layer in between because you're not using the full, advantage of Kubernetes. So if you want to extend your spot footprint, you want to save costs, that's where it becomes powerful, because normally the interruptions are the problem. You get an interruption, the application breaks, but with live migration you can move a pod from one spot to another, or even to on-prem if you want, but if there is no spot capacity available at that time. So think about long running jobs, think about training AI resources, 20-hour running jobs that currently have to run on demand because you can't lose them after 19 hours. Let's say you have a 20-hour job and you can't have them sort of like break in the middle. So using on-demand instances, and on-demand instances are very expensive. But with live migration, you can run those on multiple spot instances, save a lot of money, and there's going to be reliability as well. Let's do a demo actually. How do I change my... So you can scan this to play Minecraft. Who plays Minecraft? Some people. So let's do a demo. You can scan that on your phone. So when you... Of course the demo is breaking. No, it's not breaking. So when you click join, just click cube right, double click. Okay, yeah, it's breaking. Oh well. Let me see if the... Reset app, recommended. This happens. Demo gods are not with me. I think I know what happened. My colleague set this up and I was like, at 8 p.m. you can turn this off. Shout out to Kunal, this is the other Kunal. I'm gonna text Kunal. So we'll know if it's actually Kunal or did you stop the AWS? So he was running on his personal account and he's like, I don't want to spend too much money. So let me just check with him. Which is a bummer because it was a cool... Oh, he's texting. He's saying no. Oh.
It was running on a spot server.
No, it was on demand, but I don't know what happened. Is this working? Yeah, so this is not working. Oh well, it happens. Let me just... Okay, he's... We can do... I'll show you the demo in a minute. Let me do the giveaway, and then while he's fixing it, yeah. It's okay. So this is why I need humans. See, AI won't cut it. Okay. He's fixing it. I will do a quiz. How do I do the quiz? Let me do the quiz.